Let me ask you something that I want you to think about honestly. When did you last spend 15 uninterrupted minutes outside, face to the sky, arms bare, eyes open to actual daylight? Not walking to your car, not sitting near a window, actually outside with the sun hitting your skin. If you're struggling to remember, I need you to stay with me for the next several minutes, because what I'm about to tell you isn't a wellness tip. It isn't a supplement recommendation. It is a medical reality that most people walking into my office have never been told. And the consequences of not knowing it are showing up right now in your sleep, your mood, your bones, your heart, and your immune system, often all at the same time. And almost nobody is connecting the dots. There is something happening inside your body right now that a pill cannot fix. I want to prove that to you. Not with vague language about nature being good for you, with the actual molecular chemistry, the actual evolutionary biology, the actual physics of what happens when a photon of sunlight meets your skin versus what happens when you swallow a vitamin capsule. Because once you understand the difference, you will never think about this the same way again. Let's start in your skin. Not on it, in it. Buried in the outer layers of your epidermis, in the cells called the stratum basale and the stratum spinosum, there is a molecule your body manufactured from cholesterol. Its name is 7-dehydrocholesterol. Your cells made it, processed it, and moved it to precisely those layers, the outermost layers of your skin, the ones the sun can actually reach. It is sitting there right now. And here is what I want you to understand. It is not there by accident. It is there on purpose. This molecule has a ring structure, 6 carbon atoms bonded in a hexagonal loop, and one bond in that ring, specifically the bond between carbon 9 and carbon 10, has a threshold. It takes exactly 4.4 electron volts to break it. Not 4.3, not 4.5, exactly that. And a photon of UVB radiation, the kind the sun emits in wavelengths between 290 and 315 nanometers, carries precisely that amount of energy. When that photon reaches your skin, the bond absorbs the energy and snaps open. The ring unfolds. The molecule changes its entire three-dimensional shape in a fraction of a second and becomes a completely different compound, pre-vitamin D3, with a different geometry and a completely different biological future. Now here is the part that should genuinely stop you. Your body positioned that molecule in the exact tissue layer where UVB photons penetrate. Your skin is not passively receiving sunlight, it is actively waiting for it. The molecule is an antenna, the photon is the signal, and the system was calibrated over 400 million years of vertebrate evolution to operate exactly this way. Fish make vitamin D in their scales, reptiles make it in their skin, birds make it in their feathers and then ingest it when they preen. Every vertebrate on Earth uses ultraviolet light to drive this reaction. You are not a special case. You are the latest version of a biological system that predates the existence of bones themselves. After the ring opens, heat does the rest. Your own body temperature, 37 degrees Celsius, slowly rearranges the pre-vitamin D3 molecule over the next 24 to 48 hours through a process called thermal isomerization. No enzyme, no cofactor, just the warmth of being alive. That converts it to cholecalciferol, vitamin D3. Your liver hydroxylates it once to produce calcidiol, which is the form your doctor measures in blood tests. Your kidneys hydroxylate it again to produce calcitriol, the active hormone. And calcitriol then does something that no other vitamin does in quite this way. It enters your cell nucleus and binds directly to DNA. It is a transcription factor. It sits on your genome and instructs genes to switch on or stay silent. Over 200 genes respond to its presence. Genes governing calcium transport, phosphorus regulation, immune cell activation, cell division, insulin secretion, neuromuscular coordination, and programmed cell death. 200 genes from one photon, from one broken bond, from 15 minutes outside. Now compare that to a supplement pill. The pill gives you cholecalciferol directly. It bypasses the skin completely. It enters through your gut, where its absorption depends on how much fat was in your last meal, whether your bile acid production is adequate, the health of your intestinal lining, and a dozen other variables. The bioavailability is inconsistent, the dose is fixed, and there is no feedback mechanism telling your body when to stop. Your skin, by contrast, has one built in. When pre-vitamin D3 accumulates beyond what your body needs, additional UV exposure converts the excess into inert photoproducts, lumisterol and tachysterol, that have no hormonal activity whatsoever. The system caps itself. You cannot overdose on sun-produced vitamin D because your skin has a ceiling engineered into it. The pill has no such ceiling. The pill trusts you to read labels and your doctor to run periodic blood work. That is not the same as a self-regulating biological feedback loop. Michael Hollick at Boston University spent decades quantifying this. 15 minutes of midday summer sun on your arms and legs produces between 10,000 and 20,000 international units of vitamin D3. A standard supplement contains 400 to 2,000 units. Your skin, given a single quarter hour of sunlight, manufactures up to 50 times what a pill provides, and does so with automatic dose control. Hollick published this repeatedly. He was removed from his own dermatology department at Boston University for advocating moderate sun exposure. The institutional position was total avoidance. The photochemistry supported a more nuanced conclusion. The politics chose not to care. But vitamin D is only the beginning. And what comes next is where a pill truly has no answer. Behind your retina, layered underneath the rods and cones that let you read and see color and recognize faces, there is a completely separate population of cells that have nothing to do with vision. They were discovered in 2002 by David Burson at Brown University. They are called intrinsically photosensitive retinal ganglion cells, and they contain a pigment called melanopsin that is maximally sensitive to light at 480 nanometers, deep blue, the color of a clear morning sky. These cells do not send their signals to your visual cortex. You do not consciously perceive their activation. They send their signals through a dedicated neural pathway, the retino-hypothalamic tract, directly to a cluster of 20,000 neurons in your hypothalamus called the suprachiasmatic nucleus. This cluster is your master clock. It controls when cortisol surges in the morning to wake you, when your body temperature peaks in the afternoon, when melatonin rises at night to initiate sleep, when growth hormone pulses during deep sleep, when hunger signals fire, when your attention sharpens. Every circadian rhythm in your body, and there are hundreds, takes its timing instruction from this cluster. And this cluster receives its signal from exactly one source: light entering your eyes through those melanopsin cells. The number that matters here is lux. Indoor lighting, your kitchen, your office, your living room, produces between 100 and 500 lux. The melanopsin system needs approximately 1,000 to 2,000 lux for robust circadian entrainment. Outdoor shade on a cloudy day delivers 10,000 to 25,000 lux. Direct sunlight delivers 50,000 to 100,000. The gap between indoors and outdoors is not subtle. It is 1 to 2 orders of magnitude. If you spend your entire day inside, your circadian clock is receiving roughly 1/50th of the signal it evolved to expect. It is like trying to tune a radio when the transmitter is barely above the noise floor. The signal is technically present, but the clock cannot lock onto it. Without a reliable morning light signal, the human circadian clock drifts. Its natural period is 24.2 hours, slightly longer than a solar day. That extra 12 minutes sounds trivial. Over a week, your sleep-wake cycle shifts by nearly 90 minutes. Over a month, you are running on a completely different schedule than the planet you live on. Morning light resets the clock to exactly 24 hours every single day. It is the synchronization pulse. Without it, the system runs free, and a body running free in a world organized around solar time experiences what we call chronic circadian misalignment, which, at the tissue level, looks like disrupted cortisol rhythms, impaired glucose metabolism, dysregulated immune timing, and sleep that never fully restores. If you are over 65 and your sleep has deteriorated, if you wake at 3 in the morning and cannot return to sleep, if you feel exhausted before evening, if you never feel genuinely sharp during the day, the most probable underlying mechanism is that your circadian clock has lost amplitude. The peaks have flattened. And it is almost certainly because you are not getting sufficient light input. Your body was engineered to receive a signal it is no longer receiving. And there is an additional insult that aging specifically delivers to this system. The lens of your eye yellows progressively over decades, absorbing short wavelength light preferentially. By age 65, your lens transmits substantially less blue light than it did at 25. And 480 nanometers, the exact wavelength melanopsin requires, is precisely the range the aging lens filters most aggressively. The signal is being weakened at both ends. Less time outdoors, and a lens filtering out the precise photons that remain. Sachin Panda at the Salk Institute and others have shown that increasing morning bright light exposure in older adults meaningfully improves sleep efficiency, reduces nighttime awakenings, and sharpens daytime function. No sleeping pill resets your suprachiasmatic nucleus. No drug calibrates your master clock to the rotation of the Earth. Only photons do that, only light through your eyes at the right time of day. Now those same melanopsin cells connect to something else entirely, something that explains why so many people feel better in summer and worse in winter, in ways that have nothing to do with the cold. The retinal ganglion cells project to the raphe nuclei in your brainstem, where serotonin is synthesized. Gregory Lambert and colleagues published in The Lancet in 2002, directly measuring serotonin turnover by sampling the internal jugular vein, the vein draining the brain, in living human subjects, and correlating the production with each subject's bright light exposure that day. The relationship was linear, direct, and unambiguous. More photons through the retina meant more serotonin produced in the brain. This was not a subtle trend. It was a clear, dose-dependent relationship between light input and the brain's primary mood-regulating neurotransmitter. SSR is selective serotonin reuptake inhibitors, among the most commonly prescribed medications in the world, work by preventing the reabsorption of serotonin from the synaptic cleft, keeping whatever serotonin is present in circulation longer. Sunlight increases the production. The drugs slow the removal. Both raise effective serotonin levels. two completely different mechanisms targeting the same molecule. And because serotonin is also the precursor to melatonin, your pineal gland converts it to melatonin after dark. Higher daytime serotonin means more raw material available for nighttime melatonin synthesis. The entire light-mood-sleep axis is one continuous biochemical pipeline. Sunlight enters the retina, drives serotonin upward during the day, and that accumulated serotonin becomes the melatonin that allows you to sleep at night. Reduce the light input, and you cut both ends of the chain simultaneously. Lower mood during the day, worse sleep at night. Less energy in the morning, less motivation to go outside. Still less light input. The spiral tightens, and every turn of it is treated as a separate diagnosis. There is a third mechanism operating in your skin that has nothing to do with vitamin D and nothing to do with your eyes, and it may carry the most important cardiovascular implications of everything I'm telling you. Richard Weller, a dermatologist at the University of Edinburgh, discovered that your skin stores nitric oxide, a potent vasodilator, in chemical reservoirs distributed throughout the epidermis. These reservoirs are loaded and waiting. The release signal is UVA radiation, the longer wavelength ultraviolet that penetrates deeper into skin than UVB. When UVA photons hit those reservoirs, they break the bonds holding the nitric oxide in storage. The gas diffuses into your bloodstream, reaches the smooth muscle cells lining your arteries, activates an enzyme called guanylate cyclase, produces cyclic GMP, and the muscle relaxes. Your arteries dilate, your blood pressure drops. Measurably, reproducibly, through a mechanism that no oral medication targets. Weller controlled for temperature meticulously, using UV lamps at constant ambient temperature to confirm the effect was photochemical, not thermal. He blocked UVB to prove it was independent of vitamin D production entirely. The result held. He then made an argument that disturbed his specialty considerably. Cardiovascular disease kills roughly 80 times more people per year than melanoma. If moderate sun exposure reduces cardiovascular mortality even modestly through this nitric oxide pathway, the net effect on all-cause mortality favors going outside. The dermatological establishment did not welcome that conclusion. The data was published anyway. Now, I have to be honest with you, because this conversation only means something if I give you the full picture. The same photons doing all of this also cause DNA damage. UVB creates thymine dimers, abnormal bonds between adjacent DNA bases, at a rate of thousands per cell per hour of exposure. Your cells have repair enzymes that detect and correct these lesions continuously. The system is robust, but it is not infallible, and its capacity declines with age. Accumulated, unrepaired damage over decades raises mutation risk. Some mutations become skin cancers. This is real, and it is not trivial. But the dose is where the entire argument lives. 10 to 20 minutes of unprotected midday sun on your arms, face, and legs provides near maximal vitamin D synthesis, substantial nitric oxide release, full circadian signaling through the retina, and meaningful serotonin stimulation, while remaining well within the skin's daily repair capacity. Beyond that window, protection is sensible. Within it, the factory runs at full output, and the maintenance crew keeps pace with the damage. The biology does not ask you to choose between benefit and safety. It gives you both within a defined window. Let me bring this to where it lands in the body you're actually living in. Calcitriol, the hormone that began as a broken bond in your skin, controls calcium absorption in your intestines. Without it, your gut absorbs roughly 10 to 15% of dietary calcium. With it, that rises to 30 to 40%. That difference determines whether your skeleton receives enough calcium to maintain its structure, or whether your body, needing calcium for nerve transmission, muscle contraction, and blood clotting, begins withdrawing it from the only large calcium reservoir available, your own bones. Osteoporosis is, in meaningful part, a disease of insufficient photons. Calcitriol also acts on muscle. Vitamin D receptors exist in skeletal muscle tissue, and their activation drives genes involved in muscle protein synthesis and neuromuscular coordination. Correcting vitamin D deficiency in older adults reduces fall risk by roughly 20% across multiple clinical trials. The photon that strengthens the bone also strengthens the muscle that prevents the fall that would shatter it. Both catastrophes share one upstream input, and calcitriol activates antimicrobial peptides, cathelicidins, that macrophages deploy against bacteria and viruses. Low vitamin D means reduced cathelicidin means impaired pathogen killing. The winter respiratory infection season peaks precisely when vitamin D levels reach their annual minimum, the months when UVB cannot penetrate the atmosphere at a steep enough angle to drive the skin reaction. Before antibiotics, tuberculosis patients were placed on south-facing balconies. Niels Finsen won the Nobel Prize in 1903 for treating skin infections with concentrated light. The mechanism, cathelicidin activation through vitamin D, would not be understood for another 100 years. The clinical observation was correct long before the science caught up. So step back with me and look at what 15 minutes of morning sunlight actually accomplishes in parallel. A photon breaks a bond in your skin and initiates a hormonal cascade that governs 200 genes, builds bone, activates immunity, and maintains muscle. Melanopsin cells in your retina detect the light and lock your master clock to the rotation of the Earth, consolidating sleep and sharpening your waking hours. Serotonin production rises in your brainstem, stabilizing mood and providing the raw material that becomes melatonin tonight. UVA. Photons trigger nitric oxide release from your dermal reservoirs, dilating your arteries and lowering your blood pressure for hours afterward. No pill does all of this at once. No supplement resets your circadian clock. No capsule releases nitric oxide from your skin. No tablet fires your melanopsin cells. These are parallel systems, each evolved over hundreds of millions of years, all calibrated to the same input: the broadband electromagnetic radiation of a star 93 million miles away, arriving at your skin and eyes at the speed of light, carrying exactly the energies your molecules were built to absorb. Your body does not crave sunlight the way you feel hunger. There is no conscious signal, no obvious alarm. The deficit accumulates silently. Sleep degrades. Mood flattens. Blood pressure climbs. Bones thin. Muscles weaken. Balance deteriorates. Immunity softens. Each system declining on its own timeline, each treated with a separate medication, each addressed as though it were an isolated problem. But they share a common upstream cause, and that cause is not inside a pharmacy. The machinery in your body has not broken down. It is idling, waiting for the input it was designed to run on. The molecule in your skin is still there, positioned exactly where it needs to be, pointing at the sky. The melanopsin cells in your retina are still there, still wired directly to your master clock, still ready to lock onto the signal. Everything downstream, The bones, the muscles, the immune cells, the serotonin, the melatonin, the 200 genes waiting for their transcription factor, is still ready. 15 minutes tomorrow morning. Face toward the sky, arms uncovered, eyes open to the bright world. The photon that left the sun 8 minutes ago is already on its way. Your body has been waiting for it since before you knew it was waiting. The only variable that's missing is you, outside, where the light actually is.